Welcome back. So in here I have a structure where I have two gray beams that go from points A and C to point B. One starts from x equals at 2 meters, the other one at x equals at minus 2 meters, and then their y and z values are 0, and then both of them end up at point B, which is at x equals 0 meters, and then y equals 4 meters, and then z equals 4 meters. And then you have this cable here that holds this mass, which is 200 kilograms, and this cable, it goes over this beam till that point D. And this point D is at y equals minus 5.6 meters, and then the x and z dimensions are 0. And now let's assume that these two gray beams, they are only subject to compressive forces. And so what's the compressive force in the beam A and B? In other words, FBA, you go from B till A. If you take this B as a particle, then what's the compressive force in the beam that goes from B till point C? And then what's the tensile force in the cable from B till D? And so you need to find these three things. Try it out by yourself and then see the solutions in the next video. Thank you very much. Welcome back. So let's now find these three forces. Again, I'm going to start with a free body diagram, and I'm going to do it for point B. So let's see what we are dealing with. So first of all, I have two forces here from these gray beams, and then I have another force here due to this cable. This is your cable. Due to Newton's third law, you have the same force here and also here, so you see that your cable is in tension. And then this is your point D, and you have the same force here. And then I'm going to draw these two beams here. Due to Newton's third law, I will have the same forces here and also here. And so I have point A here and point C here. And so I have to have the same forces in this direction applied to these 2 points. So you see that these two beams are in compression. And then finally, you have 200 Gs applied to the point B due to gravity. So again, here you can clearly see that the cable is in tension, the beams are in compression. Now that's the reality. But in my free body diagram, I want to have displacement vectors from B to D, from B to A, and from B to C. I want all my displacement vectors go outwards from point B. For that, I will still have this force due to the cable that points outwards from point B, but I'm going to assume the same thing for the two beams as well. I'm going to draw this force, FBA, outwards, and I'm going to do the same thing for FBC. If I draw my forces like this, then that means that, according to this drawing, the beams would end up being in tension. It's wrong, but it doesn't matter because in the end, these two forces here should end up being negative. And then of course I have my force of gravity here. The reason why I want to draw this free body diagram like this is because then I can have all my displacement vectors, and later my general unit vectors, I can have them all originate from B. Otherwise, in case of the cable, it has to originate from B, but in case of the two beams, it has to originate from A and C. And I don't want that. It's easier if everything originates from one point. But that means that also all the forces need to originate from one point. And so I will have another displacement vector, BA, that's this one. Then the displacement vector BC, that's this one. And the displacement vector BD, that's this one here. And let me also have their magnitudes. It will be 6 meters here, 6 meters here, and 10.4 meters here. That means that the unit vectors BA, BC, and BD, it's this one here. Using these unit vectors, I can take my three forces and I can rewrite them like this. And then remember, I also have this weight force that looks like this. And so now, I will simply apply the equilibrium principle. I'm gonna add up all my J components, and it will be 0 if I sum them all up. Then the same thing here, if I add up all my J components, it will be 0. And the same thing here. If I add up all my K components, it will be 0. You can see that when you add up your I components, then this term here, it will be 0, because you're multiplying FBD by 0. So for the I component, you have this equation, which you can rewrite like this. FBA times 2 over 6 equals FBC times 2 over 6. You can cancel them out, and that means that FBA equals FBC. And if you look at it, then it makes sense because of symmetry. Then you take your J components, you add them all up and equate them to 0. Note that FBA equals FBC, so this one here, it will be FBA. So in the end, you will end up with an equation that looks like this. FBD equals minus 26 over 18 times FBA. And then you add up your K components in here. And so it will be this one equals 0. Now right away you can take this term and you can put it here. Now this FBD here, you can replace it with this one here. And this FBC, well, that also equals FBA. And so you will have an equation with one unknown. You will have FBA and then times all this equals 200G. And if you calculate your FBA from this equation, which also equals FBC, because they are equal to each other, you will have minus 2523 newtons. And from that, you can calculate your FBD, which equals 3644 newtons. Note that FBD is positive and FBA and FBC are negative. What does it mean? It means that in our free body diagram here, our assumption for FBD was correct, but our assumption for FBA and FBC were incorrect. So in reality, the forces FBA and FBC point in another direction, just like you can see it here. In here, this is what really happens. The two beams are in compression and the cable is in tension. So that's how you solve this problem. Thank you very much. Welcome back. Let's do one more 2D exercise. So I have a ceiling here that goes from B till C, and then you have two wires that go from C to A and B to A. And here you have this point A, and then another wire goes down from here. Now you see that the wire that goes from A to B, it's 0.6 meters long. And the angle here between this wire and the ceiling is 40 degrees. And then on the other side, the length of the wire is unknown. And also the angle theta is unknown. And so you have a force here that points down, and it's 1000 newtons. Then there is another force that goes from A till C, and that's 800 newtons. The force AB is unknown. And now you have to find two things here. Considering all this information, the first question is, what is the longest L, meaning the length of this wire from A to C, considering all this information? Now here I say longest. It means that you can have several lengths for this situation, meaning that you can have this 800 Newton force and this 40-degree angle and this 0.6 meter long wire on the other side. You can have all that when this wire AC has, for example, one length, and then you can have the same configuration when this wire has another length. And so, for example, if L2 is longer than L1, then you have to find L2. And once you have found the longest L, then you also have to find this force AB. Now, in order to solve this exercise, you'll probably need to know one mathematical relationship. So I'm going to derive this mathematical relationship for you, and then if you need it, then you can apply it in solving this exercise. So here it goes. Suppose that you have some kind of function, r cosine theta minus alpha. Essentially what it means is that if I draw two axes here, and then I have theta here, and then here I have r cosine theta, then it's a regular cosine function that looks something like this. Here theta is 0 degrees, here it's 90 degrees or pi over 2 radians. Here you have pi radians, 3 pi over 2 radians. And now, if I draw another function here, r cosine theta minus alpha, and let's say that alpha equals 45 degrees or pi over 4 radians, then this alpha and this minus sign, it essentially shifts the function to the right. Since alpha equals pi over 4 radians, then it will be somewhere here, and so you have this shifted cosine function. This yellow one, it's without alpha, and then the red one with minus alpha, it takes this cosine function and shifts it to the right. And now this function, r cosine theta minus alpha, it can be rewritten like this. R times cosine theta times cosine alpha plus sine theta times sine alpha. So this is a trigonometric identity. And by the way, this r here, that's your magnitude. So in the yellow case, this would be your r. In the red case, this would be your r. And the same thing here. You will have r here, but of course, the value for the function will be negative here. And then in the red case, you have r here. So again, this r cosine theta minus alpha, it takes this place and it shifts it here by 45 degrees. And so, this expression here, I can rewrite like this. I simply open up the parentheses and I have this expression. And then I will rearrange it like this. And then I'm going to put parentheses here, and I'm going to call this one A and this one B. So in the end, I will have A times cosine theta plus B times sine theta. Then what I will do next, I will write A squared plus B squared. If I do that, then what would it be in terms of r and alpha? Well, I will have r squared times cosine alpha squared plus r squared times sine alpha squared. I can factor out r squared, and I will have this expression, and there's another trigonometric identity that says that this one equals 1. It means that r squared equals a squared plus b squared. You can see it here. This one equals this one. And now I can say that r equals square root of a squared plus b squared. And now another thing that I want to do, I want to write b over a. If I do that, then I will have r times sine alpha over r times cosine alpha. I can cancel out the r's, and you know that sine alpha over cosine alpha, that's tangent alpha. And now that's the mathematical relationship that you will most probably need in order to solve this problem. R times cosine theta minus alpha, it equals a times cosine theta plus b times sine theta. And then r equals square root of a squared plus b squared, and then b over a equals tangent alpha. And now try using these relationships in order to solve this problem. And then in the next video, you'll see the solutions. Thank you very much. Welcome back. So let's now solve this problem. You have to find the longest L for this situation and the force AB. And also, in the previous video, we derived certain mathematical relationships. This one, then this one, and this one. So let's see if we will need these relationships. So essentially, you already have your free body diagram here for point A. And again, let's define our positive x and y directions. And so let's apply our equilibrium principle for point A. This is in the x direction. You will have FAB times cosine 40 degrees minus 800 times cosine theta, and that must be 0, of course. And the same thing in the y direction. FAB times sine 40 degrees plus 800 times sine theta minus 1000, and the sum must be 0. Now, if we take this first equation, then you can rewrite it like this. FAB equals 800 times cosine theta divided by cosine 40 degrees. Then I will take this expression and I will put it here. And so I will rewrite the second equation like this. This is my FAB times sine 40 degrees, then plus 800 sine theta, and I'm going to put 1000 to the other side of the equation sign. And of course, this one here, it's tangent 40 degrees. And now I can factor out my 800 here. So I'm going to have 800 times all this equals 1000. And now what I will do, I will take this 800 and I'm going to put it here. Essentially, it equals 1.25. So in the end, I have an equation, tangent 40 degrees times cosine theta plus sine theta equals 1.25. Now you have one unknown here, which is theta, but it's pretty much impossible, at least to the best of my knowledge, to find this theta using regular algebra. However, this is where this relationship comes in handy. This tangent 40 degrees is just a number, and let this number be A, which is this one here, because you have cosine theta here, just like you have it here as well. And then here, well, you have 1, and so let this 1 be B. So here you have B times sine theta, and here you have B times sine theta. And so all that equals 1.25, but from here you also know that it equals R times cosine theta minus alpha. Then you know what R is. R equals square root of a squared plus b squared, so tangent 40 degrees squared plus 1 squared. If you calculate that, then it equals 1.305, because remember, you don't have any unknowns here. These are just numbers. And then you can use this relationship to find your alpha. So you know that tangent alpha equals b over a, which in this case is 1 over tangent 40 degrees. That means that alpha equals inverse tangent, and then this ratio, again, you don't have any unknowns here. These are just numbers. And if you calculate that, then it's 50 degrees. And so in the end, what you have is this expression, which equals 1.25, and you get it from here. But now that you know your r and alpha, you can replace these values. You can have 1.305 times cosine and then theta minus 50 degrees, and that equals 1.25. And now this equation is a lot easier equation to deal with compared to this one here, where you had cosine theta in one term and sine theta in another term. Now you only have cosine theta. Now you can find this theta in an easier way. You can have cosine theta minus 50 degrees, and that equals 1.25 over 1.305. And that means that theta minus 50 degrees equals inverse cosine and then this ratio. That means that theta equals inverse cosine and then this ratio plus 50 degrees. And that will give you 66.75 degrees. And now if this theta is 66.75 degrees, then you can use the sine law to calculate your length. So I will have L over sine 40 degrees equals 0.6 meters over and then sine 66.75 degrees. After some algebra, I will find that L equals 0.6 times sine 40 over sine 66.75 degrees. And that will give you 0.42 meters. So we have a length for this wire. But remember what I said before. You can have several lengths for this wire. This length is valid for this situation. With this length, you have 800 newtons here, and then you have 1000 newtons here, and you have 40 degrees here, and you have 0.6 meters here. However, is this the longest length that you can have? Well, let's see. You would agree that if this theta angle were to be smaller, then your length would be greater. Because right now, in reality, what you have is this situation. You have C here, you have B here, and actually your point A is here. And so you really have this situation where you have 40 degrees here, and then theta equals 66.75 degrees here. So that's your current situation. However, what if you have another angle, a smaller angle? Well, then your length here will be bigger. In both cases, this one is 0.6 meters, and this one is 40 degrees, and here as well, 40 degrees. That's fixed. But here, you have 66.75 degrees, so you have L1. But if you have a smaller angle, then you would have L2, and your L2 would be bigger than L1. Well, let's see if there is another angle for our situation. I'm going to take this function r times cosine theta minus alpha, and I'm going to draw it here. Let this be theta. So this would be a regular cosine function. But now, if I have r times cosine theta minus alpha here, and alpha is 50 degrees, that means that my cosine function will be something like this. So the highest point would be at 50 degrees here. And now, somewhere here, we had 66.75 degrees. So it was this one here. And it gave you this value, 1.25. Because remember, r times cosine theta minus alpha equals 1.25. So cosine here would be 66.75 degrees minus 50 degrees, which is alpha. And that gave you 1.25. So this point here gives you 1.25. But there is another point that gives you 1.25. And it's this point here. You see? This one also gives you 1.25. And since at 50 degrees, you have the tip of your cosine function, you have symmetry here. The distance between 50 degrees and 66.75 degrees, that gives you 16.75 degrees. So that's the distance between 50 degrees and 66.75 degrees. But you have the same distance between 50 degrees and that other point here. So this distance, that's also 16.75 degrees. And so if I calculate 50 degrees minus 16.75 degrees, that will give me 33.25 degrees. So this point here, that's 33.25 degrees, and it also gives me 1.25 for this function r times cosine theta minus alpha. It means that this is my other theta. My theta 1 was 66.75 degrees, but my theta 2 is 33.25 degrees. And I know that it's valid because with this theta, this expression still equals 1.25. And this expression equaled this one here. And now if I take my theta 2 and I calculate my length using the sine law, well, then I will have L over sine 40 degrees equals 0.6 over sine 33.25 degrees. So now instead of this, I have 33.25 degrees. And if I calculate my length, which will be length 2, then I will end up with this expression, and so my length 2 will be 0.703 meters. And there you go. This length is also valid for this situation, but it's longer than my length 1. And since I had to find the longest L, that's my answer. And now, with that longest L, I can find my FAB. From the equilibrium principle, you had FAB equals 800 times cosine theta over cosine 40 degrees. And now, of course, I need to put this theta inside, theta 2. So here I will have theta 2, 33.25 degrees. And if I calculate that, then I will have 873 newtons. So that's your answer. Thank you very much.